My name's Dr. Angus Nisbet. I'm a consultant neurologist in Sussex, and I have to confess that for the last 10 years, I've been um, in the process of a project writing a book on consciousness. And it's resulted in a deep dive initially for the first 5 years into philosophy, and for the second, nearly 5 years now, into physics. And what I'm going to share in this video, this is the part one of three videos, um, is the start, or the first part of the three, of this concept that I've partly come up with myself and partly derived from process philosophy, what I've called process physics, which I want to argue is the natural which I believe to be the natural way of interpreting what quantum mechanics is telling us. So it could be seen as an interpretation of quantum mechanics. And I also believe in some way special relativity is pointing towards process. Now, what do I mean by process? Well, let's just move the slide on if I can. Oh, yes. First of all, I just want to say that the main inspirations is the pre-Socratic philosopher Heraclitus, not that I ever met him, of course. Bishop George Berkeley from the 18th century, the famous idealist philosopher, and Alfred North Whitehead, colleague of Bertrand Russell, the great mathematician, who wrote a book called Process Philosophy. In fact, that wasn't what the book was called. I think it was Time and Process or something like that. Anyway, it's a little bit difficult to follow his very, I would say, colourful description of process ontology or process metaphysics or process philosophy. And what I've tried to do is to ground that. And obviously, I've taken inspiration from the great Heisenberg and to a lesser extent other quantum physicists, and also from the neurologist Russell Brain, who who thought about these things quite deeply. Um, what I'm going to argue is that we need to move away from a physics where we treat space and objects, or space and matter, as things and see them as a process. And I'm going to argue that this is, as I say, a natural way of interpreting quantum mechanics and to a certain extent special relativity. I want to argue that it may help to solve the hard problem of consciousness. And I've been surprised that I've come across quite a few or developed quite a few ideas in physics. And so it may actually provide a different way of looking at space and time in physics. So let's crack on. So the first thing is to talk about the fact that the world, according to Descartes, and I think according to our natural intuitions, is divided up into two big realms: the realms of stuff that we can measure and is extended and has location in space, what the physical realm, in other words, what Descartes called res extensa, the extended realm, and the world of the mind and consciousness and feelings and perceptions and sensory um, and sensations, thoughts and imaginations and memory. Everything that's anything to human beings has to be conscious for it to be anything. Descartes famously chopped the world up into two, his so-called substance dualism, substance being a sort of rather old-fashioned philosophical word for fundamental entity. I think that's a better way of describing it. And he said, on the one side, I have a clear and distinct idea of myself, as I am only a thinking and unextended thing. So that's talking about his mind, his conscious content, as it were, or his consciousness. And as, on the other hand, I possess a distinct idea of a body. And he went on to coin these two terms, res cogitans and res extensa. And this leads us on to the famous mind-body problem, which has had many different or a number of different terms in history, including the problem of mind and matter, the explanatory gap between the physical and the mental world, and more recently in the 90s, I believe, the philosopher of mind, David Chalmers, famously coined the term the hard problem of consciousness, describing this real problem that's difficult to solve in trying to work out what the relationship is between, for example, the brain and the mind. So I've put these two realms, if you like, res cogitans on the left, res extensa on the right. So on the left we have mind, consciousness, spirit, depending on what words you want to use. And sorry, that was on the left. And on the right we have body, the physical world or the physical universe, matter, energy, and space, and bringing those two together to see how they sort of fit together, particularly when it comes to human consciousness, but consciousness of animals as well. How does consciousness arise, if it does arise? Or in why is it correlated with stuff going on in this extended world where things in the so-called physical world have mass, volume, locality, extension, solidity, viscosity, temperature, measurable things, extended things, localized things, whereas consciousness seems to be delocalized and doesn't have location, or it's saying the same thing, doesn't have mass, volume, extension, solidity, temperature. How do we bring those two together? And David Chalmers characteristically sort of said this, there are lots of problems in neuroscience, but in comparison with trying to sort out this relationship and what it is and how these two realms come together in some way, or how we can fit them together into a single system, if you like, that is a very hard problem indeed. Now, what I want to do now is to just talk a little bit about somebody who started to cast some doubt on the physical world as we know it. This was the philosopher Bishop George Berkeley from the 18th century. He's an Anglo-Irish man of the cloth, religious. I think he was not sure whether anyway, he was a man of the cloth. And he was a bishop. And he pointed out famously in two books that he wrote, one was written in the form of a dialogue because nobody read the first one, which I can't remember the name, but the dialogue book was called Hylas and Philoneus, which were symbolizing in their names. Interestingly, Hylas meaning stuff, material, and Philonous, lover of the mind, was the other chap. And it's a more easy to read book, but I preferred the original. What he pointed out is that if you take anything, and he characteristically he took an apple, and I think he also talked about a cherry. One was in one book, one was in the other. But it can apply to any object. He said that if you think about an object and what it is, any entity, as it were, as an individual thing, all we know about it is he called them qualities, but what we would call today properties is its qualities or properties. And he said that if you took away the properties, for example, if you took away the taste, the crunch, the shape, the weight, the smell, all the properties, if you took them away, there would be no essence left. So he said that objects were just bundles of properties. Now, you may, if you're philosophically trained, think, hang on a minute, wasn't that Hume? And in fact, Hume did take that on and wrote more extensively about the bundle theory of matter, but he got it from Berkeley. So Berkeley said there's no separate essence. An object is basically a series of properties or qualities that inhere together. He then famously went on to say qualities are actually things that we perceive and are in our mind, and went on unjustifiably, and this is what Hume had problems with and argued against it, but he went on to say that means really everything is just ideas or thoughts. Ideas is the old name for thoughts, and hence the philosophy was that type of philosophy was called idealism. There's a bit of an argument about whether Plato was an idealist or a dualist, but we won't go into that. He famously said, in fact, it's misquoted as esse est percipi. In fact, he rather clumsily mixed the English with the Latin, and he said esse is percipi, which means to exist is to be perceived. I'll just read this for the sake of the recording. For as to what is said of the absolute existence of unthinking things without any relation to their being perceived, that seems perfectly unintelligible. Their essay is percipii, nor is it possible they should have any existence outside the minds or thinking things which perceive them. Of course, he was asked the obvious question, well, what about things that haven't been perceived by humans or animals or other conscious entities? And he said, oh, well, God perceives everything. So they're still in the mind of God. So they're still ideas. And obviously he was criticized for that, particularly and primarily initially by Hume. But my conclusion, I think is let's not go all the way with Berkeley. Let's just take the very important thing that he did point out, that really, if things were properties, properties rely on experience. They rely on touching, seeing, smelling, tasting. They rely on an active process. In fact, they rely on interaction between the body of the observer and the item itself that we're talking about. So the universe might well be constituted from ongoing interactions. This is what I think this fact that everything is properties actually suggests. And that might put us into this, point us towards a process universe, saying that all objects are actually the result of ongoing interactions. Now, you're probably thinking this is what quantum mechanics might be telling us, and indeed, I think it is, and I'm going to talk about that next. But let's just finish this point. So I would say that experiences are interactions or mediated via interactions with our sense organs, and that which are then interpreted by our minds, which we take to be related, well, certainly are related to our brain. Our conception of individual things, objects, is and the universe of all things, if you like, both of these emerge from experiences which involve interactions. So this can be developed further, and this is how I've developed it. I've called it the interaction argument. And what I've said is basically that to exist is to have properties. That's what Berkeley said. Properties necessitate being potentially detectable. Being detectable requires interaction with another entity, not necessarily conscious. So two objects in space without being perceived by humans could crash into each other. And in one sense, one is detected, or the properties of one by another. To interact is to produce change, because when objects interact, they do produce change. That's how we know they've interacted. And you can think of it on a macro level as perhaps like a comet or an asteroid or a meteor forming a crater in a planet. So that's away from any perception. In order to produce change, that's really saying the same thing as having causal power. In other words, being able to cause a change in something, and often an interaction results in reciprocal changes. So, for example, two billiard balls racing in one direction, or in a converging direction, hit each other, and they're both affected by the collision and go off in a geometrically described new trajectory. So coming back to Berkeley, I think we can therefore say that it's quite strongly suggests that everything exists by virtue of cause and effect. Cause and effect constitutes events. That's another way of saying it. Events necessitate a before and after. In other words, they take time. A before and after necessitates the passage of time, because it's got to be before the change and then there's after the change. So there's got to be at least time one and time t2, however close they are together, between which a change has occurred. So the passage of time is important. So actually all events are processes because they take time. There's an event that takes 0 time would not be an event. Nothing would happen if it took 0 time. So even events are processes, and thereby is just a little doubts I want to sow in your minds about, for example, the collapse of the wave function being an instantaneous thing. No event can be instantaneous because it would take no time, so it wouldn't happen. There'd be no before and after. And this also possibly applies to quantization per se, but I'm going to come to that later on in my talks. So to exist is to be a process over time, taking all that together. There are no things, therefore, only processes. Nothing is, everything is becoming. Entities flow in time. Panta rei is what Heraclitus, the pre-Socratic philosopher from about 500 BC, said. So basically what this is arguing is that the objects that we perceive, we think they're objects, but they're actually continuing processes, continuing to interact, but producing, if you like, the same outcome, conserved outcomes, to use a physics term. The other argument I want to I've sort of touched on slightly is the zero duration argument. What this is to say that to exist for 0 time or 0 duration means not to exist. If we say, let's say a subatomic particle with a very short half-life exists, it does have to have some half-life, however short, because if it had no half-life, if it had no life, if it existed for no time, then it would not exist. So existence itself, just philosophically and metaphysically, requires the passage of time. To exist is to persist over time, from time t1 to time t2. A subatomic particle has to have a half-life, as I've said, however short. All entities exist by virtue of persisting over time. So we've got another philosophical argument. We've got 2 philosophical arguments for process philosophy. There's also a mathematical argument for process philosophy. In case anyone is querying and wondering what this is a slightly different expression of Euler's identity, expressing it in terms of 2 pi, which is tau, which I'm not going to get into now, and Euler's equation, possibly giving rise to oscillations because exponentiation by a complex exponent produces rotation or oscillation. And maybe that's how the universe exists, by way of stuff oscillating, possibly originating in mathematics. I'm not going that far, but I just hint at that. So here's the mathematical argument for process philosophy, according to me anyway. Geometry obviously is spatial, however complex it is, it's about patterns in space. Geometry can be expressed algebraically. I've covered up something there, I'm not sure what that is. Algebra is an expression of, I think, yes, algebra is non-spatial, that should say there. An algebra is an expression of mathematical logic. I'm just going to stop there for a minute and change this slide so that we can continue with it properly. Right, I'll just get those slides up. We need to reshare my screen, I think. Right, okay, that's better. So geometry can be expressed algebraically in algebra, which is non-spatial. Algebra is an expression of mathematical logic. Mathematical logic is temporal only. In other words, it's non-spatial. It can be converted into spatial, into geometry, but we're talking about algebraic mathematical knowledge, knowledge or logic here. It's not extended in space. Temporal logic maps onto mathematical logic. An example of res temporalis. So this is a term I've coined as a way of bridging the explanatory gap, the hard problem of consciousness, as the other term for it, the explanatory gap between the physical and the mental world, between mind and matter. And what I've basically said is that if you've got temporal logic, mathematical logic, it is basically, in a sense, it's a realm of time only, and the reverse is true. So geometry, spatial logic can be derived from algebra. Thus, the spatial universe could possibly be derived from this temporal only, this time only realm. I.e., it could be emergent. And then I said, could the physical universe emerge from mathematics? That's obviously speculative, but it's something that has been explored, particularly by John Wheeler, the it from bit hypothesis, Max Tegmark in his mathematical universe, and Stephen Wolfram in his Wolfram's physics project, and the book he wrote many years ago called A New Kind of Science. So let's just take stock for a minute. Process philosophy actually leads naturally to process physics, so I argue. If space exists, according to this process philosophy I'm trying to get across, all these process philosophical arguments, then it must do so by virtue of processes in time. And likewise, if matter exists, it must do so by virtue of processes in time as well. Therefore, I'm going to suggest that space and matter are emergent from processes in time. But those are only the philosophical arguments. You're really going to need to hear the physics arguments, which are coming shortly. But before we do those, I want to just bring one more argument from neuroscience. So this is what I call the neuroscience argument for process physics, or the dark night of the skull. I like to quote the neuroscientist David Eagleman here, who said on a BBC documentary that he made, or that was made mainly around his research, and he was the main narrator. The brain is locked in silence and darkness inside the skull, and all it ever sees are these little electrical signals. Yet when you open your eyes and look at the world, you see everything in full color, and it looks so rich. And you're hearing music, and you're feeling things on your fingertips, and you're smelling cinnamon. Well, the point is that really all that gets into the brain is spike trains, which are basically a series of temporally organized spikes coming up nerves. This is actually a rod being waved around. Here's its position on the y-axis. This is time. And these are the neurons firing. in the retina, for example, of a guinea pig, or in the second one down in the retina of a salamander. Each little dot, sorry, each line, so that's a vertical line on here, corresponds to one neuron. Now, is it a vertical line? Let me have a think about this. No, it's a horizontal line. So that's one neuron firing. That's another one firing in response to this waving rod. So the point is that really what gets into the brain are temporal signals, not spatial signals. So the brain itself must do a lot of constructing. It must construct the spatial world as we perceive it, the world of extended things. So it's just another piece of evidence that's suggesting that maybe the world out there is just a world of things happening. But of course, then you have to say, well, what things could happen if there were no space? And where would they happen? Well, of course, there would be nowhere if there's no space. There would only be time. So space would have to become time delays, or the space would have to emerge from time delays between certain processes. And that's what I'm going to argue. So in bridging this gap between res extensa and res cogitans, I'm suggesting that by adopting a process physics ontology, we convert the res extensa into res temporalis, the realm of time only, and this provides a bridge between res extensa, the physical world, and res cogitans, the mental world. Well, I'm next going to really do the difficult stuff, which of course is the physics. I thought philosophy was hard until I started restudying physics. Physics is a deep, deep and difficult subject. And the maths is very difficult. Most of it's beyond me. But I'd like to suggest and take this forward from a conceptual perspective, but there will be some equations, so that's a slight warning. But I think they're going to be some exciting equations, not quite new, but seen in a new way. I'm going to start this by asking the questions. What actually is the physical world? What is matter, energy, space, and time, which really is what we understand by the physical world? Well, what I'm going to suggest is that what we think the physical world is, as I talked about, this extended world with all these properties, that at the fundamental level, these properties don't exist. When we get to the fundamental level, and even at the macro level when it comes to space, which I'm going to argue from special relativity, but from quantum mechanics at the fundamental level, at the micro level, the level of microphysics, as de Broglie called it when his French book was translated into English, these properties they're not there. They emerge at the macro level. So in fact, I'm going to argue that quantum mechanics in particular tells us that the fundamental world is already a res temporalis. So the hard problem of consciousness becomes really the soft problem of physics, which we just need to understand, I'm going to argue, in a process way. It's not too difficult, although there are some conceptual jumps that have to be made. And it's difficult not to think spatially, but it can be done, I'm going to argue. There's all sorts of problems like how do you get 3 dimensions and how do you go backwards and forwards in space if it's derived from time when time is only going forwards. And I do have some solutions to these problems, which I hope you'll find interesting. So I'm going to suggest that really at the end of the day, physics tells us that really the universe is already a res temporalis, and therefore it's only a realm of stuff happening. We can talk about what that is. We'll just say processes and events, but I've already argued that events are processes. Processes in time give rise to everything. So it more easily maps onto thoughts in a mind, if you like. So that's where we're going to go. I suppose it's probably sensible to tell you something else I'm going to say. I'm going to argue that time, I'm going to argue there are two types of time. There's measurable time, which is actually a rate of events, and there's a universal time. And I'm going to argue that this universal time in which everything happens is actually equivalent to consciousness. And I've called this the time consciousness equivalence principle. What I'm going to argue, I'm going to divide this into three things. I'm going to say space is process emergence. Matter comes from delimitation, from interference patterns, and that when we see orbitals of electrons and so on, that these are actually ongoing interference patterns of processes. If the process is stopped, then the orbitals would disappear, but the processes don't stop because of conservation laws. And it's these processes that actually give rise to the strangeness of quantum mechanics. I think it may well explain most of the strange features of quantum mechanics. And then, as I've already said, I'm going to argue that there is a universal time, as a non-local universal time that's non-measurable, immutable, and equivalent to consciousness, and provides order and the arrow of time. But then there is local measurable time, which, as we'll see, I'm going to argue is not time really, it's just processes within this universal time. So what about space? Obviously, its properties are that it has measurable length in 3 dimensions. So that gives us area in 2 dimensions of volume in 3. It gives location to objects. It seems to be symmetric. You can move backwards and forwards in it at will. It's reversible. Your position can be reversed, which of course you can't do with time. And it can be measured. But there are 3 different views on space historically. Famously, Newton said space was absolute in its own nature, without relation to anything external, and remains always similar and immovable. It was like he said, he believed that the universe was like a grid, had an immovable grid, and things had fixed position with respect to one another. He was a realist with regard to space. He thought it was a thing, it was out there, although he was very puzzled by the apparent instantaneous action of gravity, which Einstein had a suggestion for later. Leibniz was completely the opposite. He was Newton's antagonist and the co-inventor of differential calculus. He said, no, space isn't a thing at all. It's just a relation between objects. I believe actually that's what quantum mechanics and indeed special relativity is telling us, but we'll come to that. Marriage, for example, so Leibniz said, is an abstract or ideal thing that arises when 2 people, substances, that's the philosophical word, entities, engage in wedlock. It is neither substance nor accident, but it represents something true about those involved in the wedlock. So too, a spatial relation is a mere ideal thing, the consideration of which is nevertheless useful. So he thought the consideration of space was useful. It wasn't a real thing. It was just a relation between objects. And that was from the Leibniz-Clark correspondence. Einstein, on the other hand, was somewhere between the two. He thought space was real, but that it was stretchable, as in mass. First of all, if you travel fast enough and you are composed of mass, that would contract space, hence the length contraction of special relativity, and it would also dilate time, and hence we get space-time, which was put together by Minkowski, predominantly with Einstein's involvement. But he thought it was a thing. It was a stretchable thing, a bit like perhaps a 3-dimensional elastic material. And he called it actually an ether, which is interesting from Einstein, because in one way he didn't see space as Newton did, as a sort of fixed ether, but Einstein saw it as a stretchable ether. I think my view is that Leibniz is actually right, and that there is a different way of interpreting special relativity without really changing any of the equations, but just re-expressing them and thinking of them in a different way. So I'm going to suggest, as I said, that space is emergent and is indeed not a fundamental property, but it emerges from interactions and oscillations occurring through time, and the space represents the delays or emerges from the delays. What about matter? For something to be matter or its parts, it must have location in space, duration in time, as we've talked about, for anything to exist, magnitude in 3 dimensions. So this any string theorists out there, I'm not sure that your 2-dimensional strings can count as physical matter, or you may not say they're matter, but I think they're just mathematical. Because if you think about it, if you take the page of a book and you reduce its thickness dimension until it disappears, the other 2 dimensions will also disappear. You may argue that the surface of a black hole may be a 2-dimensional surface of no volume, no thickness, but that's another matter. What about energy? That's the other big thing. It's not the biggest. Time is the biggest problem, but energy is a bit more problematic. Newton imagined it in terms of the accumulated force in accelerating something over a distance, an integral of force times distance, if you like. We then have Hamiltonian mechanics, where Hamilton basically talks about energy, the total energy of a system, um, that was basically conserved, and there were Hamiltonian equations to look at dynamics in a different way. And then Lagrangian, the Lagrangian variation on that, where energy is the difference, the kinetic energy minus the potential energy, which is a kind of imbalance or energy deficit, or something to do with the way that energy is being changed from potential to kinetic, or vice versa. We can think of energy as the average kinetic energy, or average speed, if you like, of the particles that make up matter. But that obviously involves matter. Then we can think of electromagnetic radiation as energy, and that certainly seems to be an oscillation or a wave-like process. We can also, from Einstein's special relativity, we can work out that, or as he did, that energy is equivalent to mass. You have to have an awful lot of awful lot of energy comes out of a small bit of mass. The conversion factor is the speed of light squared, E equals mc squared. So mass, in a sense, is a form of energy. One might think of it as actual vibrational, oscillatory energy tucked away in the fluctuations that are going on, for example, in the electron or in the proton or neutron, the oscillations between the quarks and so on and so forth. And one can think of it indeed as oscillation, and certainly in electromagnetic radiation, we have Planck's famous formula that the energy is directly proportional to the frequency, just multiplied by a factor h called Planck's constant. Everybody gets very excited about it, but I'd argue it's just a conversion factor to get things into SI units, and you could easily say E equals F, energy equals frequency. It's the same thing. So again, that actually gets the idea of process, because frequency is something happening. Gets across the idea of process. Energy is the power to change, and that can be seen sometimes as information. But I'd also point out that it can be the power to stay the same. And that may be a way of thinking about inertia. and, for example, inertial mass. Well, the real difficult one is time. Augustine of Hippo summed it up. What is time? He asked. If nobody asks me, I know. But if I want to explain to a questioner, I don't know. Does time flow, or do only events in time flow? Time is asymmetric. There's the arrow of time down the bottom in that bottom right-hand picture. You can't travel backwards in time. You can only go forwards. That rate may seem to change depending on how you measure it, and how fast clocks are running in situations where there's very high speeds, so-called relativistic speeds, or in the presence of a significant gravitational field, which affects GPS satellites, etc., without going into that too much detail at this point. We've already talked about the relationship between existence and time. To exist, you have to exist during a period of time, however short that is. I've just put in there the example of muons, which have a half-life of 2.22 nanoseconds, but they last for, on average, that long, or half of them are gone in that time. But so they have a duration, they have a lifetime. If it didn't have a lifetime, it would not exist. For something to stay the same, it must be the same at T2 as it was at T1. So even for something to stay the same, it's another way of saying that for, existence requires time. We've already talked about change requiring time for there to be a difference between T1 or before and after T1 and T2. So time is necessary for cause and effect. Time is measured by things that basically cycle, clocks of some sort. And what is a clock measuring? It's measuring either something that oscillates or something that rotates. The very high sensitivity clocks, very high accuracy clocks, use cesium-133 atoms, where I don't quite understand how it's all done, but it uses a laser to give energy to these electrons that switch backwards and forwards between so-called hyperfine, very close together energy levels very fast. And that's how atomic clocks work. And you can work out the rate by some kind of resonance. Interferometry, I think, is used. If I've spoken out wrongly there, I do apologize to any physicists in the audience. So I've really talked about the fact that physics is where the problem is in trying to solve the hard problem of consciousness. It's not as I initially thought in philosophy or in neuroscience. The problem is, I would argue, that we need to see the physics world as different. We need to convert it and see it as a load of stuff happening, oscillations and interactions through time, and then it will map on to the other world, the res cogitans, the world of the mind. Just to whet your appetite for what I'm going to do to try and further soften you up on the physics front, is I just want to ask the question, what's holding these two little Chinese boys up? And the answer is they're on a glass bridge, so it's a sheet of glass. But glass just gives us a clue about how empty matter actually is in terms of what it's made of. And in fact, if you just imagine, you think about matter as made of solid stuff and non-solid stuff, in other words, the protons and the electrons and the neutrons, then it's 99.999999, I can't remember how many nines, they're just down there, percent empty, even when assuming subatomic particles are physical or solid. But in fact, even the particles themselves, we now know, are not solid, and solidity arises from interactions between particles, the so-called Pauli exclusion principle, or principles, perhaps. So it's just a nice clue that, again, that solid stuff is not quite as solid as we think. Particles, waves, and fields, it turns out, are metaphors. Where fields, even in quantum field theory, are still a metaphor. They're a metaphor that Faraday invented when he saw swaying cornfields, and he thought, in 3 dimensions, that's what magnetic and electric fields are. They're just like the 3-dimensional equivalent of a cornfield with potential, well, with numbers, if you like, values or magnitudes at all points in the 3-dimensional space where the field was. Particles turn out to be a kind of idea based on, if you like, little ball bearings, but in fact their solidity and their location, their locality, the orbitals and covalent bonds, which are combined orbitals, which make them up, actually arise from interactions, and waves, again, just a metaphor. Just to soften you up a little bit more, I want to argue that we don't really know what the physical is. We don't really know it as well as we think we do. And one illustration is to think what we know about 4 ball bearings arranged as they are there. Which do we know is more true or real, or which is more true, real, or better known? The mathematical facts that there are 4 of them and that they can form a square, that's the geometry, or the fact that they're made of metal and have mass. Because then we have to say, well, what is metal and what is mass? And it all gets very complicated. And we haven't quite kind of completed the understanding of physics yet. So the maths is better known than the physics. And then we're going to this is by way of introduction to quantum mechanics. And I think probably I'm going to stop at this point and do the rest on a subsequent talk, because we've got to talk about quantum mechanics, and then we've got to talk about special relativity.